Welcome to Curie Electronics. Today we are solving first 40 questions of SDSC SHAR Technician B Electronics question paper. The exam was held on 14/2/2024. In TV transmission, type of modulation used for picture is it is amplitude modulation, and for sound it is frequency modulation. The unit of a quantity, the prefix tera signifies 10 to the power 12. How many distinct states a D flip-flop has? A D flip-flop means just a data flip-flop. Data will be there, and there will be a clock. We will have output Q and Q complement. Q and Q complement. So the data can be either 1 or 0. So only two states are there for the D flip-flop. Signal generated used in laboratories generally utilizes which of the following oscillator? It's a Wien-Bridge oscillator because of the low frequency, stability and cost. The temperature coefficient of an extrinsic semiconductor is, extrinsic semiconductor means doped semiconductor. That we know it is negative temperature coefficient. How do we say? We have transistors. Transistors with rise in temperature, what happens? It will go for thermal runaway. That is due to the this negative temperature coefficient. Which of the following device has lowest propagation delay? Lowest propagation means fastest logic family. That is the emitter coupled logic. Calculate the voltage drop across R1 and R2. So here we can, two methods we can solve it. Either you have to find the total resistance, and we can find the drop. That is here RT equals to R1 R2 upon R1 plus R2. So which equals what is 10K? 10 multiplied by 100 ohm, we can write it as 0.1 upon what is the value? 10.1. So what you get? It will be 1 upon 10.1. How much does it come? 1 upon 10.1. It comes to 0.099. That is the RT. So V equal to I into R. So our R is always in kilo ohm. I is in milliamps. So 0.1 amps I can write it as 100 milliamps. So I into R equal to 100 multiplied by 0.099. So which comes to 9.9 volt. This is one method. Otherwise you can use the current division rule also. You can use to solve this. So option B is the answer. Option B is the answer. Fourth layer of OSI reference model of communication protocol is here. Fourth layer is the transport layer. The power factor of a circuit is unity. Its reactive power is, to have a reactive power we should have a inductance or capacitance. But here is if the power factor is unity, means the circuit is consist of only resistance. So its reactive power is 0, equal to 0. In a transistor, IC equal to 100 milliamps, IE equal to 100.5 milliamps. Then the value of beta. Beta equal to IC upon IB. So here, what is IC? IB? IB equal to IE minus IC. So it comes to 100.5 minus 100. So you'll get 0.5 milliamps. So here IC upon IB, that is 100 upon 0.5. It comes to 200. Which type of strain gauge has better resolution? This I have checked the answer key. This is the semiconductor strain gauge. Which of the following devices can be used for high voltage application? High voltage application we use IGBT. IGBT in generally 1200 volt, 2400 volt, 5000 volt, 10,000 volt. In that specification, this IGBT is available. IC 7912. This 78078 series X78XS. This is the positive voltage regulator. And 79XX. XS means 05, 1, 12, 12 05, 0, 05, 12, then 15. That 15 means 15 volt. 05 means 5 volt regulator. These are the negative voltage regulator series. So it is a negative voltage regulator. A binary code of n bit can be used to store dash distinct elements of coded information. They are saying to store. So from the memory location 0 itself we can start storing. So it is 2 to the power n. Which of the following is the value equal to 1 terabyte? 1 TB, terabyte equal to 1000 gigabyte GB. Then so 1 GB equal to 1000 MB, megabyte. Then 1 MB equal to 1000 KB. Now, what is the question? 1 terabyte equal to what? See, 1 terabyte. First, if I multiply by 1 TB, first I will multiply by 1000. So it comes to gigabyte. Again I will multiply by 1000. It comes to megabyte. Now again if I multiply by 1000 KB, it is 1 terabyte. So answer is option D is the answer. In a transistor, the collector region is made. Collector region is always physically bigger compared to the emitter and base region. That is for the power dissipation, greater than the emitter region. In a full wave rectifier uses 2 diodes. The internal resistance of the diode is 20 ohm. The transformer RMS secondary voltage from center tap to each end of the secondary is 50 volt. The load resistance is 980 ohm. The mean load current will be, mean load current means average load current. So in the bridge rectifier center tap rectifier circuit, so if we have 2 diodes, this is grounded, then load will be connected across load and ground and this is the RL. So this diode is having a 20 ohm forward resistance. RL is 980 ohm. Then it is 50 volt. With respect to ground, it is 50 volt. That is the RMS value. Then what is VP? VRMS he has given us 50 volts. So V peak equal to 50 multiplied by root 2. So this gives 70.7 volt. This is 70.7 volt. Then what is their V peak here done? What we need? We need the current, load current, mean load current we need. Now total resistance, what is the current is flowing through the load through the forward resistance of the diode, that is 20 ohm. So we need current. So I peak, what is I peak? Equal to V peak upon total resistance, that is RL plus RF, forward resistance of the diode. 70.7 upon 20 plus 980 ohms. So it is 70.7 milliamps we'll get. These are all these kind of problems, how to solve everything I explained in previous many videos. Okay, so 70.7 milliamps now we got. Now what is the mean? This is the peak load current. What is the mean load current? I mean equal to 2 times of the I peak upon pi, similar to the voltage, output voltage of the rectifier. So DC current only flowing, correct, to the load. So it is 2 multiplied by 70.7 upon pi, 3.141. You will get 45 milliamps. So 45 milliamps is the right answer. Space wave propagation of a signal happens. Space wave propagation means what? See, 3 to 30 megahertz we will use for the radio communication. So it will go and hit the ionosphere and come back to the earth. If you increase above 30 megahertz, it will just escape to the space. There the satellite communication starts. So it is above 30 megahertz. Is a space wave communication. A triangular wave is obtained by integrating a square wave. Integrator means what is there? We have a resistor and a capacitor to the ground. Here we will give a square wave. We will get a output. What we will get? A triangular wave. We will get a triangular wave. So by integrating square wave. Capacitor is formed by storing energy in the form of electric field. What is the value of R1 required in the given circuit to produce the indicated output voltage Vout? So here what is the Vout equation? Vout equal to minus, this is an inverting amplifier, R2 upon R1 multiplied by Vin. So here minus 6 is the output. So minus, what is R2? R2 is 400 upon 400 upon what is the 400 upon what is R1? R1 we have to find, multiplied by voltage we have to take it in a volt. So 0.12. So this negative sign cancels. So 6 times R1 equal to 400 multiplied by 0.12. So which equal to R1 equal to 400 multiplied by 12.2 upon 6, which equals so we can write it as 4 multiplied by 12 upon 6 2 times. So it is 8. What is the unit? Kilo ohms. 8 kilo ohms. So you will get as the answer as 8 kilo ohms. Transient current in electrical circuits are associated with, transients are related with the energy storage components, inductor and capacitor. So both A and B. The audible frequency range in the communication, that is 20 Hz to 20 kilohertz. This 550 kilohertz to 1600 kilohertz, that is the medium wave frequency. for the radio communication. The input voltage applied to a circuit is 1 volt RMS and output voltage is 1 millivolt RMS, net gain of the circuit. In the dB they are given. Gain in dB equals 20 log V out upon V in. So which equal to 20 multiplied by log 10, okay, this is log 10, equal to V out. V out is 1 millivolt. That means 1 multiplied by 10 to the power minus 3 upon 1 volt is the input, which equals 20 log, we can write it as 1 upon 1000. What is log of 1000? That is 3. Log of 1 by 1000 minus 3. So minus 3 multiplied by 20. It comes to minus 60 dB. Minus 60 dB is the answer. The ripple output frequency of bridge rectifier is 50 Hz. Rectifier in 50 Hz supplies. That is the 100, 2 times of the supply frequency. For a bridge rectifier, it is 2 times of the supply frequency for full wave rectifier. So 100. What is the decimal equivalent? We have to convert this hexadecimal to decimal. So how do you convert? AB3, that is given in hexadecimal. We have to convert it into decimal to the base 10. So what you will do? You will multiply by 10. So A means what? 10. 10 multiplied by, this is in the position of 16 to the power 0, 16 to the power 1, 16 to the power 2. So 10 multiplied by 16 square plus B means 11 multiplied by 16 to the power 1 plus 3 multiplied by 16 to the power 0, which equals 2560 plus 11 multiplied by 16, 6611, 671, 176, 176 plus 3 multiplied by 16 to the power 0, 1, 3 multiplied by 1, which comes to 2560 plus 1763. So 9, 13, 67, 2739. So first is the answer. In Class C amplifier, Class C amplifier is an amplifier whose output current flows for less than 1/2 of the entire cycle. Feedback is generally used for. We will use feedback for oscillator as well as amplifier to produce oscillation to change the characteristic of an. So both A and B. What is the responsivity of a light detector? That is the input, that is the ratio of electrical output upon optical input. So it is the ratio of diode output current to optical input power. Correct? Yes. The switch is initially open. What happens to the intensity of the lamp when the switch is closed? See, if you closely observe this is a Wheatstone bridge. It's a Wheatstone bridge. See, all resistor values are R. That means the Wheatstone bridge is balanced. So when the switch is open, there is no current flow through the R. So if you make the R short circuit also, nothing will flow. So what happens to the lamp? Lamp current will not, lamp remains same. Intensity of the lamp remains same because it's a balanced Wheatstone bridge. And instead of galvanometer, they have shown the R parallel with the switch. BCD. BCD 81. Binary coded decimal. 8 how do you represent? 1 0 0 0. 1 how do you represent? 0 0 0 1. So option C is the right answer. In a broadcast super heterodyne receiver, mixer input must be tuned to the signal frequency to receive the signal. This I have checked the answer key. I hope this is the right answer. Which of the following determines the capacitance of a capacitor? That we know. C equal to A epsilon naught upon D. So option D is the right answer. In a super heterodyne receiver, in the intermediate carrier frequency, IF is 455 kHz. For the circuit shown below, considering ideal op-amp, the value of V out by V in. This we know it's a voltage follower. Voltage follower. If it is an ideal, it should be equal to 1. Practically, it will be less than 1. A periodic square pulse signal with on time 0.2 second and off time 0.8 second. What is the duty cycle of the signal? What is duty cycle? Duty cycle equal to on time upon on time plus off time. On time plus off time. In percentage, if you want, multiply by 100. Multiply by 100. So which is equal to 0.2 upon 0.8. 0.8 plus 0.2. 0.2 is the on time. Multiplied by 100. How much will come? 0.2 upon 1 multiplied by 100. So it is 20%. So 20% is the answer. Which of the following is accurate of all the ADCs? That is, the integrating type is the accurate, and flash is the fastest, and sigma delta uses oversampling. What would be the approximate thermal voltage corresponding to an ambient temperature of 27 degree? That is, for the room temperature, this thermal voltage is 26 millivolt. An etchant used in PCB making. Normally we use ferric chloride, but industrially they use cupric chloride. What is the power dissipated by the resistor in the below circuit? So in this circuit, if you see, the resistor is connected between Zener. So at this point it is 8 volt, and this end it is 15 volt. So potential difference we have to take. What is the I? I equal to V upon R. What is the V? V is the potential difference. 15 minus 8 upon 1K. So it is 7. What is the unit? Milliamps. Now what is the power? Power dissipation equal to I square R. I square. So it is 7 square multiplied by 1. So it is 49 milliwatt. 49 milliwatt is the answer. 49 milliwatt. So we have completed the first 40 questions. Tomorrow all of you are having the exam. All the best for your exams. After that I will solve the remaining questions. Thank you for watching.